stand amazed at the grandeur of creation. We open our eyes and are amazed. We find creative design, but we also find chaos. How do these things coexist? Is one perceived and the other real? If so, what is true? For what are we all yearning?
Good morning. I'm Don Patton, and welcome to What is True. We're continuing our series of lessons on the laws of science. I believe that we see God's ordinances reflected there, as David indicated. We talked about the laws of science, particularly the laws of thermodynamics, last session, and we hope you were able to see that. If not, you can go back and watch that on YouTube. The first law is the law of conservation that says things continue. You can't create something out of nothing. The second law says things go downhill, the principle of entropy increase, and we see that in the world around us, which is a difficulty when we understand all of the information that's involved even in the simplest cell. I think we see it illustrated in the world around us when we see animals going downhill. We looked at the fossil record for many of these creatures last time. All of the counterparts in the fossil record are much, much, much larger. And when we look at the world around us, we see the same downward trend, which illustrates that second law of thermodynamics. The whole world, universe, is going downhill. We look at processes like this, and is this uphill or downhill? Very dramatic erosion in Grand Canyon. In fact, we're told that there's 127.5 billion tons eroded into the ocean each year by the erosion around the world. We can put little gizmos in the mouths of rivers and multiply it times the flow, and you get a pretty good estimate. Now, that's not helping the continents any. That's enough to fill a freight train that would reach all the way to the moon and halfway back. That's being dumped into the ocean each year. Now, how long could that last and we still have continents? Well, you can do calculations pretty easily, and that's about 60,000 years it would all be gone. Well, it's still there, and it's not disappearing. Certainly not 4.5 billion as we're being told. It fits much better into the young Earth concepts. We look at the universe around us in the sky, and there we see even more dramatic, deteriorative processes. On an average night, a good observer can see about 100 meteorites streaking across the sky. Here's something that's come apart that is burning itself out of existence, often smashing itself onto the surface of the heavenly bodies around us. The moon has nearly 5,000 craters. Mercury is described as a cratered inferno by NASA. It's just been beat to a pulp by things that have come apart, bashed themselves out of existence against the face of it. This is not an uphill process. We look at the beautiful comets, and we see them coming apart, as here the Hale-Bopp comet, split into two. Notice the statement here by Fred Whipple of the Smithsonian Astrophysical Observatory. Comets tend to split in pieces, particularly when they're near the sun or Jupiter. Also, when they're quite undisturbed in space, comets tend to tire out and die. Well, that is not a surprise to the creationist who expects that to be happening. The evolutionist says, no, it ought to go the other way, but where do we see it? The most dramatic thing that we see is the sun in our sky, and it's dissipating about 4.5 million tons per minute through thermonuclear reactions, we're told, not counting the solar flares and prominences or the solar wind, streaming out tremendous amounts of mass. Here, some of the solar flares are seen compared with the Earth. Massive amounts blasted out of the sun. Normal stellar processes then dissipate 4.5. In addition, the solar wind, another 1 million tons, not to mention the flares and prominences, at least 5.5 million tons per minute. Well, there's a lot of mass there, but that can't last forever, and it's certainly going downhill, isn't it? Dramatically downhill. Now, that's an average sun, an average star. Let's multiply that times billions and billions, and you see what's happening in the universe. It's not uphill, it's dramatically downhill. The 700,000 billion stars, we're told, in the universe are like our sun, an average one that is just going downhill pretty dramatically. And then besides the normal stellar processes, we have things that produce planetary nebulae that blast out 20 to 30% of the mass into the space around it. We have the novas that explode, supernovas, blast themselves out of existence, really prodigious deterioration. Here the Crab Nebula is shown. According to NASA, the mess left when a star explodes. We had 4 observations of this particular Crab Nebula that happened in July of 1054. Maybe July the 4th, I don't know, but a beautiful explosion, God's fireworks, I would suggest, but it's a downhill process. The remnants that are left from these explosions, supernova remnants, are often beautiful, as with this one, described as a blinding flash which concentrated the power that equals 10 quadrillion suns. The sun was, what, 5.5 billion tons per minute dissipated into space. Now then multiply that times 10 quadrillion. You got that? That is super down. But where do the stars come from? They're all burning up and going downhill. We got to get it up somewhere, somehow. What about star birth? And we hear people talking about that, but we do not observe it, which is what science is about. Here from science, we've yet to directly observe the process of stellar formation. A lot of theories, a lot of discussion has to have happened if you're going to explain it naturally, but we don't see it. And we can't even make it work on the computers. Here, Jansen from Arizona State University School of Space Exploration says, no computer program has been fully successful in creating a virtual star from realistic initial conditions. We don't see it. And it ought to be observed if we just think about the number, even if we assume the great ages that they're talking about. We're told there are 2 trillion galaxies. That's the 700,000 billion stars. Now, if you spread that formation out over 13.8 billion years, which of course I don't buy, but let's just play the game their way, see how it comes out. At that rate, the formation rate would be 1.6 million per second. Now, if there's 1.6 million every second, I think we ought to be able to see one somewhere, don't you? No, never been able to do that. In fact, it's theoretically impossible, according to these naturalistic atheists. J.C. Brandon, in his book Sun and Stars, one of the more famous astronomers in our country, says the condensation process, that's how the gas just comes together and forms a star. Well, gas coming together. What happens to gas? You let the gas out of the canister and it comes together in a little wad, or gas pressure is spread out. We know how that works. We see the smoke from the campfire not coming together in a wad, but dissipating gradually. But here it is affected by gravity. Well, when you see the smoke from the fire spreading out, did somebody turn gravity off? No. The fact is the dissipative forces are 60 times greater than the attractive forces. Now, if you've got a force 60 times greater, I know which one will prevail. And so he says this is very difficult theoretically for this condensation process. No essential theoretical understanding can be claimed. In fact, some theoretical evidence, that is the second law of thermodynamics, argues strongly against the possibility of star formation. It goes the opposite direction. So that Godfrey Burnbridge, director of the Kitt Peak National Observatory, says if stars did not exist, it would be easy to prove this is what we expect. Well, yes, it's all going downhill. It's all dissipating. It's blowing up. And that's what we see. We've never observed one forming. We would expect that they'd all be gone by now, certainly if it's around billions of years. When we talk about star formation, we have serious problems. George Muhlfinger would be the exception to the individuals we've been quoting, who are all naturalists, mostly atheists. George Muhlfinger had earned his doctorate in astronomy from Syracuse, but he is a devout creationist, as will be obvious from his comment. But he says there are really only three things wrong with our present view of star formation. First, it's unscriptural. Now, what would be unscriptural about it? He refers to Genesis 2, verse 1, the heavens, the earth, all the host of them were finished. Okay, we don't expect an ongoing formative process. Finished, Genesis 1, or Genesis 2. In the second problem is it's unobserved, and science is supposed to be about what we observe. The third problem is it's theoretically impossible, according to Brandt and others. Well, he says you do have three problems, but apart from these three problems, it's a real winner. I think he has described the problem. But it gets worse. Not just stars that we can't explain, galaxies, which are assemblies, disk-like assemblages of hundreds of millions of stars. Frank of Durham University says we're starting from a shaky foundation. We don't understand how a single star forms, yet we want to understand how 10 billion stars form. Yeah, that just multiplies the problem, doesn't it? And these things spin, and they spin very rapidly, and that's a problem. Here just last year from NASA, the fast rotations should break them apart. When they rotate rapidly, they go apart. Kepler's third law would tell us that. The leading hypothesis as to why these galaxies don't break apart is dark matter, which we've had a hard time documenting. But these galaxies are out spinning this breakup point. Even the dark matter can't solve the problem. Of course, if they haven't been there that long, then there wouldn't be that problem, would there? The more we see, the more difficult the problems become. The extreme deep field from the Hubble telescope shows us more and sees further than we've been able to in the past, and it gets worse as far as solving problems are concerned. Here from the Gemini Observatory, they talk about the Big Bang, and looking back, there ought to be at the beginning baby galaxies, baby stars. That's what we should see, but instead we see mature galaxies right from the very start. And here's their words. It's a glaring question, why do galaxies in the young universe appear so mature? They're just like the galaxies that we see around us that are supposed to be very mature. Here in 2017, Disk Galaxy, and there are dozens of articles like this, surprises astronomers. Massive, fast-spinning, disk-shaped galaxies. So early in the history of the universe, supposed to be way back there, now we can see further, challenges the current understanding of how massive galaxies form and evolve. You go back to the beginning, you should see babies, you don't see that. The analogy that was used in Astronomy magazine was that of a nursery. Stellar nurseries, you should see babies, instead you see grandpas. And this is certainly not what's expected. One of the ways you test models is make predictions, and here they're falling on their face. James Trefil points to another problem. He's a naturalistic astronomer from George Mason University. There shouldn't be galaxies, shouldn't be stars, shouldn't be galaxies And even if there are galaxies, they shouldn't be grouped. Here's the third tier of difficulty. You've got groups of galaxies, clusters, and it just gets worse and worse. We look at our solar system and we're told in our life science textbooks, you just have a cloud and it condenses and forms the solar system. Tremendous problems with that kind of thing. You look, for example, at the fact the sun has 99% of the mass, whereas the planets have 99% of the angular momentum. That is, they're zipping around quickly. There's a slow spin for the sun, just lazily turning, but the planets are just zipping up a storm. How do you have 95% of the mass separated from 99% of the angular momentum? There is no way to explain that with celestial mechanics. It just is unexplainable. As Taylor of the Lunar Planetary Institute acknowledges, the ultimate origin of the solar system's angular momentum remains obscure. In other words, we don't have a clue. In fact, Sir Jeffreys of Cambridge says, I think the suggested accounts of the origin of the solar system are subject to serious objections. The conclusion in the present state of the subject would be the system cannot exist. Well, here it is, but no, you can't explain it naturally for reasons that, and this is not Sunday school lesson, this is laws of physics. Lister is talking about the origin of the moon. Expert from NASA, he says, all in all, developing a theory of lunar origins that could make sense of the data proved very difficult. And we could spend a whole hour talking about those problems, and he did. He goes on to say the best explanation was observational error. The moon did not exist. Well, of course it does, but you can't explain it with the laws of physics that he's trying to use. And so we see failed prediction after failed prediction. If stars did not exist, this is what we expect. Galaxies shouldn't be there. They shouldn't be grouped together. The solar system cannot exist. The best explanation, the moon did not exist. What can they explain naturally? We're supposed to explain things with these scientific laws, and even with liberal imaginations, it doesn't work. Geisler made a comment just last year, professor of physics and astronomy at Dartmouth, that I think we need to look at seriously. He is a devout naturalist. He says, when you hear very famous scientists making pronouncements like cosmology has explained the origin of the universe, that's complete nonsense. And that's true whether you're talking about stars or galaxies or novas, supernovas. The phenomenon that we observe is not explained. The second law says it's all going downhill, and to get it up is the challenge. My question is, and what we ought to ask as good scientists, is which model explains the data better? The creationist predicts a perfect beginning from which it deteriorated when sin was introduced into the world and we degenerate down to dust. Whereas the evolutionist says, no, everything increases and comes into existence as a result of present laws. So what do we see? The world we live in is going downhill dramatically, isn't it? The life of the past indicates it was bigger in the past and is going downhill, contrary to what you're often told. When you look at the universe around us, it's blowing up and burning up and going downhill dramatically. Which model explains the data best? As a good scientist, I think the answer is obvious. Asimov wrestles with this challenge. As far as we know, all the changes are in the direction of increasing entropy, of increasing disorder, increasing randomness, running down. Well, if that's what we see, then there's an obvious question. The universe was once in a position from which it could run down. How did it get into that position? There's the question. Natural law says it goes this way. You got to get it up so that it could go down if you're a naturalist, but natural law says, no, you can't do that. Everything we observe, all changes are in the direction of running down. Now, this is the atheist acknowledgement. How did it get up so that it could run down? How did it get into that position is truly the question, isn't it? Whether we're looking at the animals from life of the past, or whether we're looking at our own bodies, and we look at buildings, we look at the stars, it's all going down. How did it get up to the point where it could go down? He doesn't have an answer to that. H.J. Lipscomb is a famous atheist, professor of physics, University of Manchester, writing in Physics Bulletin. He says, I think, however, we should go further than this and admit the only accepted explanation is creation. Now, he's not a creationist. He's an atheist. He says, I know this is anathema to physicists, as it is to me, but we must not reject a theory we do not like if the experimental evidence supports it. Now, this is what the law says. The law says it goes down. Well, how do you get up so you... There's one explanation. There are some people who will just face it, take off the blinders and say, here's the evidence. This is what it says. He's still an atheist. I don't understand that. Two men who are very brave scientists made a comment in the introduction of their textbook in classical thermodynamics that indicates definite bravery and fessing up to this implication. We see the second law of thermodynamics as a description of the prior and continuing work of a creator. This will get him into trouble. Nevertheless, this textbook is used as the primary textbook in undergraduate thermodynamics throughout the country. And people will sometimes say, well, now, Dr. Patton, you don't know thermodynamics. You're a hard rock geologist. And okay, I don't know as much as a lot of people know about it. I understand that. I understand the basics, I think. It says things go downhill. We can understand that. But these men do understand thermodynamics. They wrote the textbook that's used more commonly than any other in the country on the subject of thermodynamics, and this is what they say it means. Even atheist professors of physics from the University of New Hampshire say, well, that's the only explanation. You've got to have something supernatural to get it up so that it could run down, because natural processes don't do that. I think that's dramatic, and it's obvious. Paul says we can look at this universe, the things that are made, and see the divine nature of God, His eternal power, from the creation, from the things that are made. Look at it. Even the atheist says, wow, that's the only reasonable explanation. And here are two men who certainly know thermodynamics, who say this is what it means. It says there was a creator that supernaturally made everything up here so that everything begins to run down from there. You look at the world around you, that's what it says. We're glad you're listening and studying with us and considering the laws of science. We'll continue that, Lord willing, next Sunday. We'd like to have you come worship with us at the Little Rock Church of Christ, meeting at the Breckenridge Shopping Center. We'll be there at 9:30 this morning, and then at 10:30 for worship. We appreciate you listening, and thank you for being with us this morning.
eyes unto the hills. Where does my help come from? My help comes from the Lord, the maker of heaven and earth. I lift my eyes unto the hills. Where does my help come from? I'll praise you in this storm, and I will lift my hands. You are who you are, no matter where I am, and every tear I've cried, you hold in your hand. You never left my side, and though my heart is torn, I will praise you in this storm. I lift my eyes unto the hills. Where does my help come from? My help comes from the Lord, the maker of heaven and earth. I lift my eyes unto the hills. Where does my help come from? I'll praise you in this storm.